We're going to look at functions today. Now, a function is defined as every number you put in can have one and only one number that you get out. The numbers you put in are referred to as your domain, which is also known as your dependent variable. Independent variable. Um, what you get out is referred to as your range. That's referred to as your dependent variable. If you're dealing with x and y, what you put in for x is your independent variable, which is your domain. If you're dealing with y is what you get out, which is your range or your dependent variable. Now, here we have a function, f of x is equal to an x squared. And f is just the name. Could be Abigail of X or whatever. It doesn't make a difference. So F is the name. What's in parentheses is what you plug in. On the right-hand side, we have our rule. And in this case, our rule says, I don't care what you put in, I'm going to just square it. So when we're looking at f of -6, you got to plug -6 into our rule, which says input squared. We square that, and in this case, we can simplify it and get 36. Even f of 3. So we put 3 in, and our rule says whatever you plug in, you square it, and in this case, we get 9. Once again, our rule says whatever you plug in, you got to square it. In this case, we're plugging in triangle, so you get triangle squared. Here we're plugging in a box. Our rule, once again, is whatever you plug in, you square it, so we'll plug in box, so we'll get box squared. Here we just have an input of A. So our rule says whatever you plug in, you got to square it. So I'm going to have an A, and I have to square it. Same idea here, f of -A. So whatever I plug in, I got to square it. I'm plugging in -A, plug in -A, and I have to square it. So pretty much whatever's in your parentheses is what you actually plug into your rule. And in this case, our variable of x only shows up once on the right-hand side. It could show up in more than one spot, depending upon the problem you were given. Here it says we got to go and plug in A and do the opposite of that. So if I plug in A, I would get this, and I have to do the opposite, so I'm going to put a negative in front of the whole thing. So I square my A and then do the negative, so I end up getting -A squared. Here I need to do f of A, get that answer, and then add f of h. Well, f says your input squared, and your input in this case is A. After I do that, I need to go plus, and I need to do the same type of thing here where my input's h, so I get h all squared. So once again, whatever is in your parentheses is what you plug in for your rule. And once again, on this one, our rule was input squared. In this case, we have triangle plus box as our input, so our rule says we need to take our input of triangle plus box and we need to square it. Well, we could go ahead and get rid of the parentheses here. We know that squaring means multiplying by itself. So we're going to have triangle plus box times triangle plus box, and we could FOIL that out and collect our like terms. Here we have x plus h as our input, so if we follow our rule, x plus h is our input, we have to square that, and then we could work that out. Because it's being squared, it means x plus h times x plus h, and then we have to square it. Your difference quotient is something, if you would choose to take calculus, that you'll deal with a lot, and you'll get very familiar with it in calc. Now, your difference quotient is two things on top subtracted. So I bring down the subtraction sign, big fraction bar over just an h. So this one says f of x is what I have to subtract. So that's just my original function, which was x squared. What's before the subtraction sign, I need to go to f and plug in x plus h as my input. But remember, my input squared is what my rule says to do. My input is x plus h, and I need to square that. So it's x plus h squared. Notice this f of x plus h is identical to what we just did here. Minus f of x, which is our original function, over h. So this right here, we already worked out over here. Now, could you work it out as an x plus h times an x plus h and FOIL it? Yes. You would still get down to this. Bring down what's after our subtraction sign. Now we can go ahead and just simplify this. You'll notice here that your x squareds drop because one's positive, one's negative, leaving you just with that 2xh plus an h squared all over h. Notice on top you have a common factor of h. We could pull that out. Then we end up having h times the top and h times the bottom, so these h's that are highlighted would drop, leaving us only with what's in the parentheses. Now for this problem, let's also go ahead and look at our domain and range. Domain is what you put in. Well, we can put in anything we want here. So our domain is going to be all real numbers. Your range is what you get out. Because we're squaring it, and if we put in a positive and square it, we know we get positive. If you put in a negative and square it, a negative times a negative is positive, we know we're not going to get out negatives. So your range is y is greater than or equal to 0. Because we could actually get out 0 if we plugged in 0, because 0 squared is 0. So we're, for the most part, doing the exact same thing for this problem. Here's a different function. It's called g. It says take your input squared divided by your input and add 1. So input squared over input plus 1 is our general rule. And we're plugging in what's in our parentheses of -3 in both of those input spots. So in this case, it would be a 9 over a -2. So here we have our input being box. We got to follow the general rule, input squared over box plus 1. So our input was box. So we're going to have box squared over box plus 1. Here we're going ahead and plugging in 1 over a. So we need to have our input squared over our input plus 1. Input squared, our input was 1 over a. Plug in 1 over a also here. Now all we have to do is simplify this because we happen to have fractions within a big fraction. So we have this. There's a couple ways we could do this. We could square the top, square the bottom, which would be this. Now, you could write the bottom as one fraction by doing a common denominator. Then you'd have a fraction divided by a fraction, and you could multiply by the reciprocal of the bottom. That would work. Another way, we could look at what's our common denominator of the whole top and the whole bottom of the whole thing, which happens to be a squared. So I'm going to multiply the top by a squared and the bottom by a squared, which happens to be a special form of 1. Multiply the top by 1, 1 over a squared times a squared just happens to be 1. A squared times 1 over a happens to be an a. 1 times a squared happens to be an a squared. So whichever method you choose to simplify this does not make a difference. What we have here says to go 1 over g. So I'm going to put 1, and now I just have to do f of g on the bottom. Well, once again, or not f of g, g of a. So I'd have to go ahead and go my input squared, which is a, over my input of a plus 1. So here's my original function, but because it's 1 over my original, I go 1 over what I originally had. But now I have 1 divided by a fraction. Instead of dividing by a fraction, I can take my 1 and multiply by the reciprocal of this. Well, multiplying by 1 doesn't change it, so it is just this ugly color right here of an a plus 1 over an a squared. So we can continue on looking at this one here. G in our inputs is square root of a. So I still need to go ahead and input squared over input plus 1, but my input's the square root of a, so I'm going to have the square root of a squared over the square root of a plus 1. Now in this case, the top simplifies. My a and my square root cancel each other out. The bottom I can't do anything with. Now I could go ahead and get the root out of the bottom by multiplying the top and bottom by the conjugate. There'd be nothing wrong with doing that, and probably what you should do when you get to your homework. This one says I need to do g of a and then do the square root of the whole thing. So that's why I'm doing the square root of this whole thing. F of, or not f, g of a means I got to put in a, which would be my input squared over my input plus 1. So I'm doing the square root of the whole thing. So then I could do the square root of the top, square root of the bottom. The top does simplify. Square root of the bottom I can't do anything with. Typically we don't like to leave roots in the bottom, so we're going to multiply by the special form of 1 of the square root of a plus 1 over the square root of a plus 1. Then we're going to go ahead and multiply the top, which is just a times my root. On the bottom, I get the square root of a plus 1 all squared, so my square would undo my square root, leaving me with a plus 1. Next one, I need to go input squared over input plus 1 because that's my rule. My input is triangle plus box, so it's triangle plus box squared over triangle plus box with that plus 1. There's nothing we can do to the bottom, but remember triangle plus box, all squared would be triangle plus box times triangle plus box, so we could FOIL that out. Over here, we have g of x plus h. Same type of thing. X plus h is our input, so we've got to go our input squared, so x plus h all squared, over our input plus 1, so x plus 1, or x plus h with a plus 1. So you could FOIL the top, x plus h times x plus h, and we get this in the bottom. So now we're going to do the difference quotient for that last problem. Difference quotient, once again, is you're subtracting your original function all over h, and it's putting in x plus h to begin with here. So I still have it all over h with a minus sign. This is my original function, which was input squared over input plus 1. Our g of x plus h, that's what we just did on the last problem, which happens to be input squared, which is x plus h squared, over our input, which is x plus h with a plus 1. Now we have fractions within fractions. We just have to simplify this. To do that, we're going to subtract our fractions. We have to do common denominator, which happens to be x plus 1 times x plus h plus 1. So we need to take that first fraction, top and bottom, by an x plus 1 to get our common denominator. So this red's a special form of 1, which multiplying by 1 doesn't change it. Take our second fraction, multiply it top and bottom by a special form of 1, which happens to be the other part to get our common denominator. So multiply the top and bottom both by that. So now our common denominator, x plus h plus 1 times x plus 1, is what we have on the bottom. Multiply these two here together on the top, and we get this. So you'd have to FOIL this out, get an x plus h times an x plus h, which is an x squared plus 2xh plus an h squared. Then you'd have to multiply that by your x plus 1. If you do that, you get this maroon color here. Then we could do that same type of thing over here, distributing through our negative x squared into our parentheses. Now, we originally had where we were dividing by h, which is really dividing by fraction. So instead of multiplying or dividing by fraction, I'm going to multiply by the reciprocal. And the reciprocal, if I can get this out of here, is 1 over h. So now we're going to look at the top and we're going to start combining like terms. You'll notice that you're going to have your x cubes. They're going to cancel because one's positive, one's negative. Your xh squared are going to cancel because one's positive, one's negative. Your x squareds are going to cancel because one's positive, one's going to be negative. So I'm going to write what's left, which happens to be all these three brown things. Yeah, sorry about that. My highlighted blue things I did not have right. This is an x squared h, this is an x squared h, so it gives us one of those x squared h's. Bring down this one here, bring down this one here, bring down this one here. You'll notice at this point, sorry about that, we have an h that's a common factor on the top, so we could pull an h out of everything. Then we have h times the bottom, h times the top. These h's would drop, leaving us with what's in the parentheses on the top over what's on the bottom.